Hello everyone, you are watching Code with Shubhajit, and today we will be solving one of the easy problems from Geeks for Geeks, which is chocolate distribution problem. Okay, so let's try to solve this problem so that everyone gets chocolates properly. Okay, so let's go through the problem statement once and then we can see what needs to be done. So we are given an array of positive integers. Each value represents the number of chocolates in a packet. Okay. Each packet can have a variable number of chocolates. Okay. So these are the packets actually. So first packet contains 3 chocolates, then 4 till 12. So we have some 8 packets here if you can see. The size of this array is 8. Right. Okay. Now we have m students in this case, which is 5. And the task is to distribute the chocolate packets among m students such that each student gets exactly one packet. Okay. It means that there are 5 students, right? One student might get this packet with 3 chocolates, one might get 56, one might get 9, one might get 1, sorry. And the second condition is the difference between maximum number of chocolates given to a student and the minimum number of chocolates given to a student is minimum, and return that minimum possible difference. Let's get to the one note and understand the second condition properly, and then we can see how the solution will look like. Okay. And I have taken the same array as we have in the problem statement, and the m value was 5. Okay, so now what we have to find, that given 5 packets from this array, we have taken some 5 packets from this array. We have to see the minimum value of those packets, the maximum value of those packets, and we have to find the difference between them, and that difference should be minimum. Can you see that we have 5 students? They will be getting the packets from here. Okay, let's say one of them get packet number 3, one of them got 9, let's say one of them got 56, some got 9, again there are 2 9, and one got 12. Then what is the maximum and the minimum difference? The minimum is 3, the maximum is 56, the difference is 53. Can you see it here? Can we minimize this 53? That is our task. So the very logic here, or the very requirement here, where let's say we have some m elements, which in this case is 5. So we will be having these 5 elements, and we want the minimum and the maximum, and we want the difference to be minimized. This actually motivates me to sort the array. Why I'm saying that? Because let's say we have these 5 students. Each of them will be getting some packet from here. Let's say if the array is sorted, these 5, then this will be the minimum, this will be the maximum, and whatever in between will be between the maximum and the minimum. Okay, and we just find the difference between them. We just find the difference between them, and that difference will give us the output. Okay, and then we will also be having one uh, smallest diff, let's say smallest diff variable, which will keep track of the smallest diff of our 5 packet window. Okay, so now I am going towards the, or introducing you towards the actual approach of the solution. So if we actually sort this whole array, let me sort this out and then I can explain you further. So we have sorted the array. Now what my approach would be, whatever m is, so m is 5, so we will take the windows of size 5 and we will be traversing till the end. So in our case, if we take this window of size 5 from 1 to 9, as it is sorted, we know that the maximum element will be the last element, that is 9. The minimum element is the first element, that is 1. So 9 minus 1 is 8. So let's take the smallest diff, SD. Let's take it as SD, smallest diff is SD, which is 8 for now. Okay, so now moving forward to the next 5 element window, we have 3, 4, 7, 9, and 9. Now if you see here, we have a difference of 6 here. So now the smallest difference will change from 8 to 6. Now we will go to the next 5 element window. 12 minus 4, the maximum element is 12, minimum element is 4, which will make us the difference as 8, but 6 is lesser, so we'll not update this 6. Now the last window is 7 to 56, so 56 minus 7 is 49. 49 will also not be updated because 6 is definitely lesser than 49. Okay, now can you see that how the logic goes? Okay, how the flow is working, and why I need to actually sort the array? Because if I sort the array, then it will be really easy for me to find the maximum element and the minimum element in big O of one time, like in constant time, because the last element is the maximum element, the first element the minimum element, and I find the difference between them, and I update the smallest diff variable, which I'm keeping track when we are traversing the whole array. And that's the whole logic of the problem. Okay, I hope you are able to understand this. Before going to the solution, I just want to tell you about the time complexity here. So we have to sort it here, right? So sorting takes n log n time. And the next is we will be moving in terms of the 5 or the m packet or the m element window, and that is something which will be traversing once for the whole array. So this is the first window, second window, third window, fourth window. So it actually depends on the number of elements which we have in the array, so big O of n. So the total time complexity is big O of n log n plus n, which actually boils down to big O of n log n. Okay, taking the maximum. Okay, the logic and explanation part is done. Now we should get into the coding part. Okay, so at first we need to sort the array list of integer, which is arr. Okay, so collections.sort arr. Now I will also find the size of array, which I can do with arr.size. I am able to use the size because of this array list, because it is an array list, so it gives us the method size, which will give us the size of the array. So this is done. We will also have a variable smallest diff is equals to integer dot min, not min, max value. Why max value? Because whenever we are storing the max value in the smallest diff, next time whatever smaller element will come and we compare it with that to find the smallest value, this smallest diff will get the minimum value. I will explain you that. It might be a bit confusing about the explanation. So what I'm saying that smallest diff, okay, smallest diff is plus infinity. Okay, integer dot max value, let's take it as plus infinity for now. It will be having some value very large. Okay, and we are taking some element, let's say 20. Okay, now we want to find the smallest element among 20 and plus infinity. What it will be? It will be 20 only. That's why we take this as plus infinity. We take this as such large so that whenever we want to compare it with someone else for the first time, this value will get the smallest diff, and from the next time, okay, it will be comparing it with 20 and so on. Okay, I hope you are able to understand that why we are taking the smallest diff as the max value. Now I will be running the for loop, and this for loop will actually uh, be moving in terms of our m element window from the start till the end of the array. Okay, so what I will do, int I is equals to 0, I is less than, here I will not go till the end of the array. If I show you why, if you see here, uh, I was 0, right? Going from here, and till which point we have gone? We have gone till this point, okay, which is I is equals to 3. So from I is equals to 0, we have gone till I is equals to 3. We haven't gone till last. Why? Because we have a 5, m is equals to 5. That is the 5 element window we have, and that actually ends here. So what's the constraint? I will be going from 0 till I should be going till n minus m. What is n here? N is 8. The size of the array is 8. 8 minus what is m? 5, which is 3. So that's why I'm saying I is less than or equals to n minus m. I hope you are able to understand that. And then I plus plus. Okay. In this, what I'm gonna do, I will update the smallest diff. What is smallest diff? It will be math.min of smallest diff, comma. What is the next value? That will be the difference between the maximum and the minimum of the window. So if I'm taking this window, this is the 5 element window we have, the initial 5 element window, the minimum and the maximum. What is the difference? 8. So I'm comparing the smallest diff with 9 minus 1, that is 8. And what the values will be? This is I, and what is this? This element will be from I will be moving m elements minus 1. So I plus m minus 1. What is that? I is 0, What is m? M is 5 minus 1. What is the index coming? The index coming is 4. And that is the index which I am actually targeting. So this window from 0 till I plus m minus 1, I have to find the difference, the maximum and the minimum element. So that will be ARR of I plus m minus 1. Okay, so I have to understand that this is not an integer array, this is an array list. So we have to use the get method for finding the value for a certain index, which is I plus m minus 1 and minus arr dot get I. Okay, this is done, and now we will just return this smallest if. Okay, this is the whole logic. Let me compile and run and see if it passes the basic test cases or not. Okay, our expected output and my output is same. I will highly encourage you to actually solve this problem on your own. Also do a dry run with some random examples. You will be able to understand how the flow is working, okay, and how the windows are moving till the last. And do submit it and see if all the test cases pass or not. If you have any doubts, please put them in the comment section. I will be really happy to help. And that's all for today.